Hey guys, let's solve this problem. Leetcode 1008, construct binary search tree from preorder traversal. So given an array of integers preorder, which represents the preorder traversal of a BST, a binary search tree, construct the tree and return its root. It's guaranteed that there is always possible to find a binary search tree with the given requirements for the given test cases. A binary search tree is a binary tree where for every node, any descendant of the node left has a value strictly less than the node val, and any descendant of the node right has value strictly greater than the node val, right? So a pre-order traversal of a binary tree displays the value of the node first, then traverse the node left, and then traverse the node right. So as you can see in this graph, this is it's a BSCT, right? Because all of the nodes, as you can see, all of the nodes from the left side are less than 8, right? As you can see, all of them are less than, right? And for five also, all of the nodes from the left are less than this five, right? And all of the nodes of five from this node are greater than five, right? All of the seven is greater than five, right? And for eight, if you can see, all of the nodes from the right are also greater than eight, right? So this is a BSCT. So we are asked to construct a BSCT from pre-order traversal. A pre-order traversal is just traversing the left side of the subtree first and then the right side. So a pre-order, yeah, that means we traverse the left side, then the node and the parent node, and then the root node, and then the right subtree. So so we have given this we have given a pre-order array, right? We have given a list. So how do we build a basicity from this given pre-order list, right? So to build a basically from this given pre-order list. So one thing we have, for example, the root is just known, right? The root is just 8, right? So one thing what we are going to do is, let's say we start from 8, right? Then we have 5, right? So we will compare the value of 5 with 8, right? The value of 5 is less than 8, so it goes to the left of 5, right? The left of 8, right? Because its value is less than its parent, right? So once we are at 1, the value of 1 is less than the value of 5, right? It goes to the left of 5, right? It goes to this way. And when we are at 7, we have to add it to the right side of 5, right? We have to add it to the right side of it, because we can't add it to 1, right? Because we cannot add it to the left because its value is greater, and it cannot be the left of 5, because it has to be the right of 5, right? So we will add it to this side, right? We will add it to here. So when we are at 10, 10 is cannot be added to the left side of 8, right? It has to be added to the right side of 8, right? It's gonna be at this point, right? It's gonna be here. And when we are at 12, 12 is gonna be at the right of 8, and at the right side of 10, and it's gonna be at this side, right? It's gonna be 12. So we will build this way. So to solve this problem, one thing we can do is we can use a stack, right? So let's say we will add 8 first in our stack, right? And let's create first the root, right? 8 is the root, right? Then let's say we have 8 is the root, right? So we have 8 here. So, and we will add a trinode root, trinode, uh, the root, that's the root is 8, right? We will add it to the stack, right? Let's say 8 is in our stack, and then whenever we found another element, let's say we start from this side, right? We start from 5, and we will compare the value of 8 to 5, right? The value of 5 is less than the right of the value of the value of its root, right? 8. So we will move it. We will make it the stack root. Stack, the top of the stack is 8, and its left is gonna be its left is gonna be five, right? It's gonna be five, and we will add this five to our stack. And let's say in our stack we're gonna have eight and five, right? And the total stack is now five. And next, what we're going to do is we will see one, right? One is less than five, right? The total stack is five. One is less than five, and it goes to the left of five, and we'll add one here. Then when we are at seven, seven is the value of one is less than the value of seven, right? So yeah, the one is less than seven, right? So at this point we cannot add it to the left, right? We will try to find the parent of the one which is greater than seven, right? So pop we will pop this and this whenever this value is greater than or equal to seven, right? So our, let's say, the node we have popped for the last is gonna be five, right? So this node is the parent of our seven, right? It's gonna be the parent of seven. So at this point, we have found our parent, right? The parent is five, right? So it's gonna be like what we're going to do is the parent of five dot right, five dot this five node, the node with value five dot right is gonna be seven, right? So we're gonna make it this seven. Then the top of the stack is now is gonna be we have eight and seven, right? The top of the stack is now seven, right? And when we see 10, the value of 10 is greater than all of this, right? Well, I'm gonna pop them all of them, and I'm gonna pop all of them, and the last node we have popped is eight, right? It's gonna be the parent, right? The parent is gonna be eight, right? It's gonna be eight, and 8 root right is gonna be 10, right? It's gonna be 10 here. Then we will add our to our stack, we'll add 10, right? Then when we see 12, 12 is greater than 12 is since 12 is greater than, we will pop this and the parent is gonna be 10, right? Then 10 this 10 root right is gonna be 12, right? So I'm going to solve this problem this way. The time complexity is gonna be of n and the space is gonna be of n, right? So let's see, let's go to the implementation. So first I'm going to have a root, right? The root is gonna be the pre-order list at zero index, and we'll make this trinode, right? Trinode, I mean trinode. Instead of trinode, it's gonna be trinode. I have a trinode of we start for a pre-order of the right. So this be the root, and our stack is gonna have the root, right? So I'm gonna have this. So for index, let's say in range of one up to the length of the pre-order, right? Then n is length of pre-order. Pre-order. So iterate over this to this point. Then if not stuck, I'm going to check. If not stuck, I'm going to just add it to a stack dot append stack dot append pre-order of tree node of. So it's gonna be three. So I'm gonna add tree node of pre-order at index, right? Then what if else if the top of the stack dot val is if it is greater than the pre-order at index. At this point, what we're going to do is stack at this left is gonna be three node at pre-order pre-order of at index, right? It's gonna be this one, and what we're going to do is stack dot append and the left, right? The top, right? The top of the stack dot left, right? We're gonna add this to our stack. Then what if there's the opposite? We need to have a parent. Let's say our parent is initially none. Then while stack and the top of the stack val is greater than, while this is less than the pre-order at index. While this is true, I'm just stack dot pop, right? A pop from the stack. Whenever whenever this is false, I'm gonna have the parent, right? So what I'm going to do is parent dot next is, I mean right is dot right is gonna be pre-order of index, right? It's gonna be a trie node, right? A tree node, I mean tree node of this. So we can have this, and once we are done, what we are going to do is, yeah, we add it to the stack, right? Stack dot append parent dot right, right? So we will add this to the stack. Then once we are done this, what we are going to do is we just return the root. So let's see if this works or not. Okay, preorder is not defined, so let's preorder. So preorder, you go on all of the places. Preorder is the lesson is not an instance of tree node and int. Okay, dot var, sorry. We have to check the var instead of instance, right? Okay, so whenever this is okay, parent dot right is gonna be, what if this parent is, oh sorry, I have to assign this parent with this one, right? Yeah, as you can see, all of the test cases in this in the given test cases are passed. So they say if it works for all of the test cases. So as you can see, it passed for all of the test cases. Thank you very much. If you like, please subscribe.